So here we have an example for the complete combustion of methane. And so we've got methane plus oxygen gives us water, carbon dioxide. That's complete combustion. If it were incomplete, we'd see carbon and carbon monoxide. What we're doing is we're taking one methane molecule, adding it to two oxygen molecules, and it yields or produces two water molecules plus one carbon dioxide molecule. Okay, so what if the number of methane molecules that we used in our as reactant and reacted with oxygen was 6.02 times 10 to the 23. Hopefully that's a number that you recognize right now. Okay, that's fine. So we can go through and basically identify how much oxygen that's going to consume, how much water that's going to produce, and how much carbon dioxide that's going to produce. So we would just use ratios as we have all along. So the oxygen to methane ratio is 2 to 1. So the number of particles of oxygen is going to be equal to 6.02 times 10 to the 23 times 2 over 1. So that gives us 1.204 times 10 to the 24 molecules of oxygen. Okay, so for that 6.02 times 10 to the 23 number of methanes, we're going to react that with 1.204 times 10 to the 24 oxygen molecules. Okay, now how much water does it make? Well, the ratio of water produced from the CH4, the methane, as a reactant is also 2 to 1. So the number of water molecules produced, again, it's going to be 6.02 times 10 to the 23 times 2 over 1, same as the last equation, 1.204 times 10 to 24. Okay, and then finally, how much carbon dioxide is produced? We'll have to take the ratio of carbon dioxide to methane, and that ratio, if we look up here again, is 1 to 1. So the number of carbon dioxide molecules that are produced in the reaction is going to be 6.02 times 10 to the 23 methane molecules times the ratio here of 1 over 1 gives us okay, 6.02 times 10 to the 23 molecules of CO2. Okay, so there we have it. So we had a reaction. It was one molecule of CH4 gets together with two molecules of oxygen, and it produces two molecules of water plus one molecule of CO2. Okay, and then using that equation, we were able to figure out that if we had 6.02 times 10 to the 23 of methane, instead of just one particle, we used this many particles, we'd end up reacting that with 1.2 times 10 to the 24 number of molecules of oxygen and producing 1.2 times 10 to the 24 molecules of water, and also producing 6.02 times 10 to the 23 molecules of carbon dioxide, which, if we convert that into moles, would be 1 mole of methane, 2 moles of oxygen, 2 moles of water, and 1 mole of carbon dioxide. So as you can see, the coefficients that we had in the initial equation match up with the number of moles in this line here. So what we're saying is the ratio of particles in the equation is equivalent to what you'll end up with your mole ratio between materials as you're dealing with larger samples. So a mole ratio is equivalent to the particle ratios in the chemical reaction. Okay, so we're going to use the mole ratio in this next example here, where we've got lead chlorate reacting with 16.4 moles of aluminum, according to this equation shown here. And first question that's being asked of us is how many moles of lead chlorate will react with the aluminum, the 16.4 moles of aluminum. Okay, so we can go ahead and try to figure that out. First thing we will want to do, not surprisingly, is figure out what the ratio is, lead chlorate to aluminum. So just write this down. So I'll start with number 1 here. Lead chlorate to aluminum. The ratio is going to be, okay, so look over here. It's 3 is the coefficient in front of lead chlorate, and 4 is the coefficient in front of aluminum, so the ratio is 3 to 4. So therefore, if we're trying to figure out the number of moles of lead chlorate, PbClO3, 4, okay, that's going to be equal to the number of moles of aluminum, 16.4, times the ratio, which is 3 over 4, 3/4, okay, and that's going to be equal to 12.3 moles. Okay, so for 16.4 moles of aluminum reacting with lead chlorate, we'll end up having 12.3 moles of that lead chlorate that it reacts with. Another way that you could have done this, maybe easier for some students, is to write out the equation. So we'll just do that. 3PbClO3 4 plus 4Al gives you 3Pb plus 4AlClO3. 3. Write out the equation, and then you know you've got 16.4 moles of aluminum. Write the 16.4 over the 4 in the aluminum, and then set that equal to a number x over 3. And that gives you your same ratio, and it's easy to figure out because you're given the 16.4 moles of aluminum, so you just put it down here over top of the aluminum in the equation, and you're trying to find out how many moles of lead chlorate will react with it. Okay, so just above the lead chlorate, above the coefficient here, you put your x in, and now it's a simple case of cross multiplying. So the x value is going to be equal to 3 times 16.4 all divided by 4 here, and that works out to the same answer. It gives you your 12.3 moles. Okay, some of you may find that an easier method to get to the correct answer. It's up to you how you choose to do it. Let's move on to the second question that's asked here. How many atoms of lead will be produced in this reaction given that 16.4 moles of aluminum were used and reacted fully? Okay, so we'll start out by doing a molar ratio. Okay, so the ratio is going to be lead atoms in the product to excuse me, aluminum atoms in the reactant, and that ratio is the same as the previous example here. So it's going to be 3 to 4. 3 leads are produced for every 4 aluminum atoms. 3 to 4. Okay, so number of moles of lead will be equal to 16.4 moles of aluminum times the ratio 3/4. Okay, and that gives us our 12.3 moles of lead. Okay, but we're not finished. Notice that question said, how many atoms of lead will be produced? Well, so far we've done a good thing. We found out how many moles of lead will be produced, and we needed to do that first. But now we'll just go a step further and say, okay, the number of lead atoms is going to be our 12.3 moles of lead times Avogadro's number, (6.02 times 10 to the 23 atoms per mole. So when we multiply that through, we end up with 7.40 times 10 to the 24. Okay, and there you have it. We've learned so much in life from Barbie, and I hope Barbie has been helpful in helping you understand a little bit more about chemistry today.